Hello to everybody. Welcome to the 4th International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Let's start the session. First paper belongs to Shatman Saqib. Shatman Saqib is online.
Hello, assalamu alaikum. Good morning, sir. Good afternoon, sir.
Hello, hello.
Salman Saqib is not available, so on behalf of my co-author, I am Muhammad Abu Bakr Siddiq, so I am going to present today's paper.
Okay, please, you can start your presentation.
Okay, thank you, sir.
You have to at most 10 minutes.
And sir, if possible, please kindly update the speaker name in the website. So because.
Okay.
Yes, sir. Can you see my screen?
Yes, I see.
Good afternoon and assalamu alaikum. Welcome to our presentation on prediction of temperature and rainfall in Bangladesh using long short-term memory recurrent neural network. So today's speaker is Muhammad Abu Bakr Siddiq, and I'm currently working as a faculty member of International University of Business, Agriculture and Technology in Bangladesh. Okay, so let's start our presentation. So why we need to forecast weather, why we have to forecast temperature and rainfall. So there are several reasons for that. The first reason is that, so there are several seasonal outbreaks that may happen in the future, and to predict those seasonal outbreaks, so weather forecasting plays a very important role there. And on the other hand, agricultural forecasting. So if you want to forecast what kind of crop we like to cultivate and what kind of fruits, seasonal fruits we like to get, so then weather forecasting like temperature and rainfall forecasting is very important. And again, for disastrous management, event management, so weather forecasting is very, very important. And understanding weather pattern changes. So if we like to understand what pattern of weather will be going to follow in the future, so in that case, the weather forecasting plays a very important part to know the changes of weather pattern. And again, the impact of weather on economic growth, and that is what you can forecast by forecasting the weather in the future coming years or coming decades. Next, the objective of this study. So here we are going to implement a machine learning approach. More specifically, it is a deep learning approach, and that is called recurrent neural network. And the enhanced version of recurrent neural network is called LSTM, long short-term memory neural network. And that is what we are going to implement here for the month-wise temperature and rainfall prediction of Bangladesh specifically. And we are going to analyze the temperature and rainfall data for 115 years, and that is 1901 to 2015 of weather data of Bangladesh. So we have collected the data set. So this is an open data set available in Kaggle public domain data set. And the data set name is Bangladesh weather data set. Here we have the average rainfall and temperature data for 115 years of Bangladesh weather. And from those 115 years, we have used 113 years of data for training our prediction model, and remaining 2 years of data was used to test the prediction performance. And let's see what happens. So we have made the averages for temperature and rainfall data of Bangladesh from 1901 to 2015. And if you look at the bar plot here, the left bar plot is for, temperature average. So, for each and every month, so January to December. And this January is the average of all 115 years data from January 2000, 1901 to January 2015. Similarly, February, March, all up to December, that is the average temperature for all 115 years. You can see, so for January, it is like 18 degrees Celsius. And if you look at the right bar plot, you can see that that is rainfall in millimeter. So in January, there is very less rain. On the other hand, if you look at July, that is the highest rainfall, like 520 or 30 millimeters there. And those are the average rainfall for 115 years for each and every month from January 1901 to 2015, December. So here is our overall work. So we have the temperature and rainfall data for 115 years, average temperature, monthly temperature and rainfall data. And from those data, we have pre-processed, we have used the data pre-processing technique. Like if there are some missing data in our Excel sheet, then uh, we have put the predicted data for those missing data. So our missing data calculation process is something like this. Suppose we miss the data for February, February 2015 or February 2013, then how we can predict that missing data for February 2013? We take the average of January 2013 and March 2013, and we also take the averages for all the 115 years February data, and by putting the average of all those February data and before, 1 month before, that is January, and 1 month later, that is March data. By putting all those average, we came a value for the new data for the missing data. And after data pre-processing technique, we have used the LSTM model to predict the temperature and rainfall. And first, we have trained this LSTM model by using 113 years of temperature and rainfall data. And after training the model, we test the model with 2 years of remaining temperature and rainfall data, that is 2014 and 2015 of Bangladesh weather. And let's see how the performance is there. So, okay, so we already covered this, and then, okay. So let me talk about the methodology, I mean, the model, how this model works a little bit. So actually we have used the, I mean, enhanced version of standard RNN neural network that is called LSTM neural network. So if we look at the RNN neural network, at each time step, the model gets the current input as well as the model gets the previous output as an input. So that means it is a like feedback, there is a feedback. So that means output is fed back to the input, something like that. So, and there are several layer of RNN and 10H activation function there. And that means this 10H function actually uses the output between -1 and +1, and then it gives the input. And if you look, and the problem is with RNN, so this RNN has one problem, that is vanishing gradient distance. So so it has problems. So if you want to predict the long-term, long-term data, so you know that in time series data there we have long-term dependencies. So for those kind of long-term dependencies, gradient is vanishes, and that's why the RNN cannot perform in time series data properly if there is long-term dependencies. And to solve this problem, there is the LSTM neural network. In LSTM neural network, if there is some long-term dependencies, like in time series data, those long-term dependencies problem can be easily solved in LSTM neural network. And you can look at here. So in LSTM neural network, we have a cell state here. So this cell state will always remain there. And if some new value, so, and there are also three layers you can see here. One is called forget layer. So this sigmoid layer, starting sigmoid layer, it is called the forget layer. So, and this sigmoid layer getting input from st-1, old output, and from new input xt. And it's depending on the old output and new input, it's put a value between 0 and 1. If it puts a come up with a value 0, that means it will uh, so all the previous value in the cell state will be forgotten. And if it comes up with a value depending on the this st-1 and xt, then of 1, then all the previous value of ct-1 will be kept. So after that, we have an input layer. So this input layer, we are giving a new input by this input layer. Okay, so you can see here, input layer, there are two layers. So we have a sigma layer here, and we have a tan ace tangent layer there. So by this sigma layer will come off which input we have to push through this valve, and after that this tan ace layer decided it's come up with the input vector, and it's added with the cell state, and then we get the updated cell state CT. And the last layer is called output layer. So this sigma, output sigma, it decides which CT will be kept as a current current output or future output ST. And then tiniest layer quizzes those values between -1 and 1, and that forward as a output ST. Okay, so in our model, we have 100 hidden layer, 100 hidden LSTM data layer, and for optimizer, we have used ARM optimizer. The task of optimizer is to update the weight and biases of the neural network so that we get the less loss. Loss function will be reduced. Our task is to, the optimizer task is to make the loss function close to 0. And for our case, we have used the loss function mean square error, and the ARM optimizer will update the weight and bias by feeding it back to the neural by backpropagation algorithm, and it will update the loss function, and it will make the loss function close to 0. And for learning rate of the optimizer, we have taken 0.001. And you can see here how the architecture of LSTM layer here. So we can see output is fed back to the input. So that means for LSTM layer, at each time step, memory gets both current input and as well as it is getting the previous output. So now let's look at the results. So for temperature prediction, if you look at the error, mean error, so our mean error is minus 0.38. And what is actually mean error? It is the predicted value minus the actual value. If you compare the predicted value minus the actual value, and if you make the average of all those, then you get the mean error minus 0.38, and we get the standard deviation 0.63 degrees Celsius, and we get the absolute deviation of error 0.53 plus minus 0.5. For the rainfall prediction, we get the mean error that is minus 17.64 millimeter, and the standard deviation 145.13 millimeter, and we get the absolute deviation of 107.11 plus minus 97.05 millimeter. And okay, so by looking at the value, it may be difficult to guess. Let's look at the curve, how it looks like. So if you look at here, so we have used the 113 years average temperature, monthly temperature and rainfall data for training the model. And after training the model for the year up to the year 2013, we have predicted the monthly temperature for the year 2014 and 2015. And if you look at here, so the actual prediction and the actual value and the predicted value of 2014 and 15 in this graph at the left side, you can see they are really converging at each and every places. And if you look at the right side box plot for actual and predicted value, you can look at for both the cases, I mean, the median value is close to 27, I think. So yes, so for predicted value, it is close to maybe 27.5, and for real value or actual value, it is like 27. And if you look at the max value, so it is like 18.5 for actual case, and for predicted value, it is like 18.3 maybe, and it's looked like 18.2 or 3, and for actual value, the max value is 18.5. So they are really close. And if you look at the 25% quartile value, then you can see it is 25% quartile. Okay, if you look at 75%, look, so both are like close to 28. So 28 degrees Celsius for real and prediction. So they are, it looks like they're really equal. And if you look at the 25% value, you can see that is 22 maybe. Yes, it's 21.8. It seems 21.8 for actual, and for predicted value, it seems 22. And if we compare these two box plot, and we get the box plot for the error, so temperature prediction error. So this is the box plot for error. So you look at the error is very less compared to, max value for error box plot is 0.6. It's like 0.6. So there is only difference is like 0.6. And if you look at the median value is almost close to 0. So that means 0 is very less. And you can also observe the curve here, and you look, they are converging very well for the prediction with the actual value. Then it is the, how much effort we have needed to get this output. So we have run this model for almost 26 efforts, and after 26 efforts, we get the convergence value with the actual and the predicted value is converged after 26 efforts. So we have stopped there for running the model for 26 efforts. Then next, if you go to the rainfall, you can see, so similar case like temperature, we have trained the model for 113 years for 1901 to 2013. Here also for rainfall prediction, we have trained the model from 1901 to 113 to 1901 to 2030. And then for 2014 and 15, we have predicted the rainfall. So if you look at the left graph, you can see the green here is the actual, green one is the, it's blue one. I think it's blue one is the actual uh, value, and the yellow one is the predicted value, and they're conversing very well, except there is a spike in 2015. Maybe there are some unexpected event happen. That's why maybe rainfall will increase, like if you have tsunami or something like that, maybe rainfall will increase. So that's why actual rainfall is slightly get a spike for 2015, but the predicted is a little bit lower for 2015. So if you look at the box plot at the right curve, you can see for actual and the predicted. So you get the median for actual, like it's like maybe 90, and for the predicted median is little bit higher. And if you look at the max value for the actual, you get higher max value, because in 2015 the actual rainfall is higher, and but for predicted rainfall the max value is like 600 millimeter, but for actual it is like 700 millimeter. And if you look at the I mean, box plot of rainfall prediction year, you can see the block spot is quite good, but you get a outlier here at 2000 millimeters. So we get a outlier here, and that is we get this outlier because of this kind of spike in actual value. You can see here in 2015. Sometimes it happens. Then, if you look at the rainfall forecasting epoch, so when these two actual and predicted value will be converged. So if you look at the loss versus epoch curve, you can see it takes a longer time compared to the uh, temperature, because in temperature you can see here before it converges at 26 epoch, and loss is uh, very low at 26 epochs. But if you look at here, it converges. So it converges, it goes again up and then coming down loss. So it converges like almost 100 epoch, I think. So it takes more time for training for the rainfall data compared to the temperature data. So in conclusion, our LSTM model, we have 100 layers of LSTM model, and we predicted the temperature and rainfall data of Bangladesh for 2014 and 15, and our result is quite good. And you get a very low mean error of minus 0.38 degrees Celsius for the temperature, and also considerably very low mean prediction error of minus 17.64 millimeter for the rainfall data. And this model is working quite good. And this kind of model can be used for the prediction of the future rainfall and temperature, or future weather data, other weather parameters data. And if we can predict that, so it will be helpful for the decision making, like what we have to, what pre-measure we have to take, and what disease may be outbreak, and what crops we like to cultivate in our future coming years. So in our future work, we have planned to implement the model for global weather forecasting, and also we are looking to enhance the forecasting accuracy by employing some other models, or by tweaking the parameters of the model if possible. Thank you very much for listening to me. If you
Thank
have
you
any
for
question,
your
you can ask.
presentation.
Yes.
Okay. Dear participant, do you have any question about this article? Okay, no question. I wish you continued success in your career, Mr. Abu Bakr Siddiq.
Yes, sir.
Hope to see you. The other paper.
Thank you so much for giving
Okay,
me.
thank you. Thank you.
Thank you so much, sir.
Okay.
Assalamu alaikum.
Shah Muhammed Nurettin. is online.
Sir, this is Mohammed Didarul.
Okay. You can start your presentation. Mr. Didarul Islam. Mr. Didarul Islam, will you present?
Hello.
Hello.
Hello, sir. Sorry for the interruption. I have some problem with the connection from here.
Will you present instead of Shah
Yeah.
Muhammad Nuruddin?
Yes, sir. I am one of the paper's author, Didarul Islam. I am representing this on the.
Okay. Please, you can start.
So thank you so much, everybody. Good noon. This is Mohammed Didarul Islam. I studied.
You have 10 minutes, please, at most.
Okay, sir. I studied at East West University, Bangladesh. First of all, I would like to thank this organization for giving me this opportunity to represent my research topic in this conference. My topic is an efficient approach for sequential pattern mining on GPU using CUDA platform. This is actually the topic I will overview all over this presentation. There are many algorithms in sequential pattern mining, but the most popular pattern growth algorithm is prefix span due to it has various advantage from others. One of them is it mines the complete set of sequence patterns, but greatly reduces the effort of candidate subsequence generation. Heterogeneous computing, which means a system which uses more than one kind of processor or core. The system not only add some type of preprocessor but also different type of core processors to handle particular task. Basically, it is the aggregation of both CPU and GPUs through high-speed interconnection. This is actually our algorithm, previous algorithm. Find length 1 sequential pattern. The given sequence S is scanned to get item that occurred frequently in S for number of time that item occurs in equal to a length 1 of that item. Length 1 is given by notation. Divide search page based on the prefix that derived from first step. The whole sequential pattern set is partitioned in this phase. Find subset of the sequential patterns. The projected database are constructed and sequential patterns are mined from this database. Only local frequent sequences are explored in projected database so as to expand the sequential patterns. The cost for constructing projected database is quite high. Bi-level projection and pseudo projection methods are used to reduce this cost, which ultimately increases the algorithm's efficiency. This is the CUDA platform. It stands for Compute Unified Device Architecture, a parallel programming paradigm, which was published by NVIDIA in 2017. It allows software developers and software engineers to use a CUDA-enabled graphics processing unit for general purpose processing, an approach termed GPGPU. CUDA architecture splits the system into hierarchical structure into grids, columns, and threads. Nowadays, we need to compute a large-scale data for finding patterns from data. For computing a large-scale data, HPC system is much more reliable as it is ensuring the utilization of computing power in both CPU and GPU. Prefix span is one of the most efficient and robust algorithm for finding sequential pattern from subsequences database. In HPC subsystem, this algorithm can perform a high computation process very efficiently. These are our research challenges. Handle large scale the sequence database in a high performance computing system, implement prefix span in non-recursive way in GPU using NVIDIA CUDA platform. This is actually our objectives to implement prefix span in this high performance computing system, reducing the execution time of prefix span, minimizing required memory space in an HPC system. So there was many work have been done in this topic. We have mentioned some of them. This is actually the previous work have been done. So in the sequential CPU program, prefix span can implement in both recursive and non-recursive ways. In GPU, recursive algorithm can be implemented using dynamic parallelism API, but there is some overhead, such as there is a limitation that maximum recursion depth on kernel function is 24. In large sequence database, required recursion depth might be higher than the maximum limited depth of dynamic parallelism API. So we need to implement prefix span in a non-recursive way using stack. As we know, we can create millions of numbers of threads in GPU. We can launch up to millions numbers of blocks at a time, and each block can have 1024 maximum numbers of threads. CPU as a host transfer data over GPU for doing computation. So first of all, we need to transfer our sequence database to GPU in a way that is more efficient and faster. Our dataset is a two-dimensional jagged array, as each sequence has not the same number of elements. So we came up with a solution to pass data to GPU in a linear memory space. We converted our two-dimensional sequence database in a one-dimensional single array. For each sequence, we are storing two pieces of information in two arrays, which is the starting index and the ending index of a sequence. So our sequence database will be look like table 3. Okay, this is in our non-recursive implementation for prefix span on GPU, we use a class type of stack for storing information about a sequence pattern for further mining process. In prefix spans, there are mainly two main tasks that can do in parallel way on GPU. These are searching for frequent items. Two is constructing projected database. So we can do this two tasks in a parallel way on GPU, and other jobs will compute on the CPU as we are implementing prefix span on the HPC system. CPU as a host launch kernel function and pass necessary data for computation on GPU. Two kernel function do computation in GPU, and each thread in CUDA block will work with a single sequence. The number of thread and blocks will create during the execution time. Threads and threads number depends on the total sequence number of the sequence database. For finding frequent items in a projected database, we can call a GPU kernel function, which creates threads equivalent to the number of the sequences in a sequence database. Each thread will work with a single sequence for finding frequent items. A global memory space can use where the frequency of the items increment automatically by each thread for a particular item node. In CUDA, atomic add reads data from a memory address and updates the value of the same address space automatically. Here we can see the simulation of the kernel function where here we can see the kernel function where sequence database contains 4 different sequences. Each thread will work with a single sequence, and total number of items is 7. That's why we need 14 integers global memory space for storing frequency of items. One for only one item and in a sequence, and another for items within item set. Each thread will store individual flag value for visited items for avoiding double counting, such as here in thread 0 for item 2 already updated 1 items. So it will not call atomic add function one more time for item 2. If at a time more than one thread wants to update same items frequently, one thread will update the value of by locking that memory address and then unlock for the threads. The atomic add ensures no inconsistency frequent value. So finally, thread 3 updated the frequency value. Constructing projected database in kernel, we can only use starting index, and by using another information which is the starting index inside an item set. 3 projected database can be represent in this index format. Here is given an example of the of constructing projected database in level wise. Consider the given 3 projected database. In 3 projected database, 4 frequent items founded. So we can build projected database for all these 3 new prefix at a time, as each thread will work with only one sequence. Thread 0 will find all new start index for this 4 prefix and so on. Other thread will also find new start, and after completion of the all thread, we will get a table like figure 3, where each row represents projected database for respected prefixes. Database collections. So to measure the performance of our proposed method, we used both the real dataset and synthetic datasets. Those synthetic datasets generated using a tool that is provided by SPMF. SPMF is one type of open source data mining library. For real dataset, we used clickstream data of MSNBC website. MSNBC is a popular American news portal. This dataset is converted into sequence database from a original data, which is available in the UCI repository. In this figure, it shows the overall runtime of parallel prefix span and sequential prefix span. The proposed method took less runtime than a sequential program of the prefix span. As we introduced a technique where not storing the original database can build a projected database. That's why memory consumed by parallel prefix span is less than the sequential prefix span. In our work, we have proposed a method to compute only 2 tasks of prefix span in parallel on GPU. So still there are some limitations that we need to transfer data over and over again to GPU for computation. Creating a new threads and launching a kernel cost a lot of time and memory. In future, we can improve our method to minimize this overhead in our proposed method. And this is all of our presentation. Thank you so much.
Thanks for your presentation.
Thank you, sir.
Dear participant, do you have any question about this article? Okay, no question. I wish you success in your career. Hope to see you, Mr. Didar.
Thank you so much, sir. Thank you so much, everybody, for being with me.
I can't understand.
I thank everybody for being with me.
Okay. The next paper belongs to Seyit Amir Hüseyin Musevi. Are you ready for presentation?
Yes, sir.
Okay, you can start your presentation, please. You have at most 10 minutes, please.
Okay. So,
you have 2 papers.
Yes, I have 2 papers. At the first, I present the myopathy and neuropathy, and then I present another article.
Okay.
Am I started?
Okay, you can start.
Okay. Hello, everyone. I'm so happy to participate in this conference. Our colleague is diagnosis of myopathy and neuropathy using EMG signal and wavelet coefficient. So, as a person ages, some disease develop in people that can lead to a disruption of their life order. It is safe to say that Parkinson's is one of these diseases. The disease, first discovered by British scientist Dr. James Parkinson in 1817, is now recognized as a common neurological disorder in the elderly worldwide. Unfortunately, the reason for this is still unknown, although research has been done to determine the cause. Tremor is a regular involuntary uh, tremor that occur in different parts of the body. Tremor has a low amplitude and is caused by interference with movement control mechanism. There are different types of tremor that are associated with ET and PD, the most common of which are resting, moving, and postural tremors. The most important and common symptoms are Parkinson's disease, which has been reported in all samples. It should be noted that with voluntary movement of the hand, the tremor may disappear. Also, when patients are asleep, the tremor is clearly eliminated. On other hand, stress and anxious may take the tremor more prominent. Therefore, evaluation of tremor intensity can play an important role in disease analysis. Determination of severity of disease for the physician can play an important role in the treatment and control of the disease because Parkinson's drugs have a various side effects, in, including allocations. If there is a special protocol, the dose one of drugs and other treatment can be determined so that the person can control his disease with a minimum of medication and reduce side effects. The current protocol used by physicians not only wastes considerable time but also play an important role in performing these protocols. Therefore, it is possible to understand the severity of the disease according of this questionnaire. To the problem mentioned in the method of the current protocol above, in this project, we have tried to measure the severity of disease by measuring the accelerometer of tremor. Therefore, mobile accelerometers for size of the acceleration was selected. The reason for choosing a mobile phone is availability of this device in all places. On the other hand, due the ability to transform the data quickly and easily using a smartphone, it can be used for telemedicine and medical application in the future. We we use we use PSO algorithm is part of meta-heuristic algorithm and GA for select the best feature. For data collection in this study, we use the participant 111 people, including 78 men and 30 women, with the average of 31.56 years, were asked to download the mobile accelerometer software, which is available for free in the Apple Store and Google Play. The person takes the smartphone in his hand and puts it in the table at the rest. The special doctor determines the level of the tremor of the person from 1 to 4. So each test is repeated 5 times and the data is recorded. The data is recorded and stored in the phone and then sent to the computer for further processing. Also, all data has been recorded using iPhone 11 Pro Max. The acceleration signal is recorded in 3 directions with the frequency of 100 Hz. And this, so we use uh, we apply genetic algorithm and PSO to select the best feature. Um, the wavelet transform It is designed to address the problem of non-sinusoidal signal. It involves representing a time function in terms of simple fixed building blocks and thermal wavelets. These building blocks are actually as a family of the functions which are derived from a signal generation function called the mother wavelet by translation and dilation operation. The main advantage of the wavelet is that it has a varying window size, being broad at low frequency and narrow at high frequency, thus leading an optional time frequency resolution in all frequency range. As you see in the picture, we decompose the signal in the level of the tube and level 3. We use the mother wavelet dosages 2 and 3. Wavelet coefficient level 2 and level 3 are extracted, as you see in the pictures. In this section, we describe the result of the classification and computing time. First, the signal related to myopathy and neuropathy and healthy people. So from each person and each level of the 2 and 3 coefficient extracted. Then from each level, the feature mentioned extracted, and by employ a PSO and GA algorithm, we select the best feature. This process performed in 2.4 gigahertz and Core i7 with 8 gigabyte RAM. As you see in the Table 1, the duration process for the level 2 of the dosages and GA is 0.39. And in the PSO for the level 2 of the dosages is 0.37. For the level 3 of the dosages and genetic algorithm is 0.54, and for PSO is 0.41. The result in the table 2, you see output of the feature selection that we apply genetic algorithm and PSO algorithm for level 2 of the dosages and level 3 of the dosages. So in classification accuracy in PSO with the level 3 of the dosages, we get a 93% with 6% standard deviation. So in consequence, the aim of the study was to provide a diagnosis aid method to the physician, especially in the neuromuscular field, so that they can distinguish between people and neuropathy and myopathy from healthy people. In this study, first the signal was decomposed to the second and third level of the wavelet using Davis's mother wavelet. Then 13 feature mentioned extracted from each level. Optimal features were selected using PSO and genetic algorithm. Classification accuracy is obtained by using mean, zero crossing, standard deviation, and the best accuracy is 93%. Thank you for attention for the first article.
Thank you very much for your first presentation. Dear participant, do you have any question about this article? Okay, no question. Please, you can start your second presentation.
Okay. So the title of this article is Diagnosis of Hand Tremor Using a Smartphone, Accelerometer, and Support Vector Machine Classifier. Neuromuscular disease uh, is a name implied include disorders of the nerve field and muscle of the body. There are more than 150 type of neuromuscular disease, and they can occur in the every age. So, uh, so muscle weakness and premature fatigue in skeletal muscle are important symptoms of the disease. There are two main challenges in diagnosis disease. One of them is accuracy and other of the speed of the calculation. Few studies have reported the computation time. To increase the speed in classification, the process signal can be used instead of main signal. And in the field of classification accuracy, instead of using a selector, we should select the best feature for them. For evaluation of the tremor, intensity can play an important role in disease analysis. Parkinson drugs have various side effects, include hallucination. In this study, we asked from the people to take the phone in his or her hand, and we capture a data from the phone, and the doctor labeling each patient from 1 to 4. The mobile accelerometer software can recognize hand trauma. The person takes the smartphone in his hand and puts it on the table at the rest. Uh, so after we collect the data and transfer into the computer, we use a MATLAB software uh, to analyze the data. As you see in this picture, the signal in the x direction show in the first figure, and also signal in y and z direction you can see. Uh, we apply EMD empirical mode decomposition algorithm to process for extract modulated amplitude frequency oscillation pattern from the time series data. That this pattern are called EMD. EMD is a process for extracting uh, decomposition signal. This pattern are called IMF. For extract the IMF, we have some steps, and the number of the IMF is selected by operator or error of the algorithm. So in this study, we extract 8 IMF by selecting with the operator. So we extract a feature from each IMF and give to the input of the classifier. In this study, we employ a support vector machine classifier. And we employ a sequential forward selection that we call SFS algorithm to select the best feature. We extract mean, standard deviation, zero crossing, skewness, kurtosis, mean absolute deviation, energy, and entropy. We, we employ sequential forward selection, and SFS have an advantage, such a high speed to determine the best feature vector and simple algorithms than metaheuristic algorithms. So we For classification and compare our result to other researchers, we employ SVM with RBF kernel and three criteria: accuracy, sensitivity, and specificity. So uh, we reviewed all IMF and recorded the result of the classifier output. The result that in this table show from IMF 4 onward have very low accuracy, and the average classification accuracy drops below 35%. The classification results are as follow that you see in the table 1. The results show that the first IMF had the best classification and best accuracy. So we don't need to use the raw signal that have a high calculation time. Proper detection of hand hormone level can change the course of the treatment and physiotherapy. In this study, we use the EMD algorithm to increase the speed of the tremor detection. We extract 8 IMF from each signal, and from each IMF we extract the feature mentioned in the previous section. Due to the fact that not all features were suitable for classification, the best feature was selected using the SFS algorithm, and skewness, kurtosis, and energy, which are output of the SFS algorithm, were used for classification. The IMF 4 to 8 had a very low accuracy and below 35%, and the results were not stable. The classification results for each IMF are reported in a previous table. The results show the first IMF has the best classification accuracy with the average of accuracy 91.35%. Thank you for your attention. If you have questions, I will answer.
Thank you very much. Dear participant, do you have any question about the article? Okay, no question. I wish you continued success in your career. Hope to see you. See Amir Hüseyin Musevi. Thank you again.
Thank you very much, sir.
Okay, thank you again. The other page paper is belong to Halit Zaman. Halit Zaman. Halit Zaman is online. Lika Muhammad Hassan is online. Sadul Leva is online. Sadul Leva has 2 papers. Let's wait for a while. Is there any participant with a paper in this session? Mr. Moon, do you have paper in this session? Let's wait for a while. Okay, thank you attending in this session. I must finish the session. Have a good day.
Thank you, sir.
Okay, thank you. Walaikum salam.